Hello everyone. So today we are going to solve the missing number problem. So the question is that we are given an array of length n and we have numbers from 0 to n. But as the length is n, so we have one number missing. For example, in the first example we have an array of size 3. So we can have 0, 1, 2 and 3 in the array. But here we have 2 as missing number, so we have to return the missing number, which is 2. So the first method is that we can sort the array and then we can check for the number and the index if they are same or not. If they are not same, then the particular index is not there in the given array. So we can first sort the array and then we have to check from I is equal to 0 to I less than length plus 1, because uh, for an array of size 3 we can have 3 also in the given array. So and I will be implemented one by one. If current element is not equal to I, this means that we don't have I in the given array. And for the base cases, we have to check if 0 is there in the array or not. If the first element is not 0, then we have to return 0. And if the last element is not equal to the length of the array, we have to return the last element. And if all of these fails, we can return -1. Okay, so this will be -1. Okay, so this is the first method. So in this one, the time taken is log n, because we are sorting the array, and the space will be constant here because we are sorting in place, but it will be linear if we are sorting it by taking some extra space, and we are not allowed to modify the given array. Okay, so now the next method is we can use HashSet for adding all the numbers, and then we can check if the current index is present in the given HashSet or not. So we are creating a HashSet of integers, and we are adding numbers one by one. Here, the number we are getting one by one, and we are just adding it. We are adding the number one by one, and then we are checking for the missing element. If the set contains, if the set does not contain the given number, the given index as the number, we have to return the current index, and this will run from 0 to the length of the array. and in default case we will return -1. Okay. Okay, so this one is using hash map. So this one is taking linear time and linear space. So the time is linear because here we are iterating for all the numbers, and here also we are iterating through 0 to the length of the array. So it is 2 times of n, which is equal to linear on, and for the space we are using a hash set, so which is storing all the numbers, so the space is also linear. So this was the second method. Okay, so now the third method is that we can use XOR implementation. So XOR, so there is one unique property of XOR, that when a particular number is taken XOR with the same number, it gives 0. And so we can use this property. So for example, in the given case, if we take the example of the first example, so here we will start with the XOR as length of the number, which is 3 here, and when we will take XOR of 3 with 3, it will be 0. When we will take XOR of 0 with 0, it will be 0. When we take XOR of 0 with 1, it will be 1. And we have to take XOR of this number and the index. So index here is 0, here the index is 1, and here the index is 2. So in this, what will happen, that the indexes are 0, 1 and 2, and the numbers what we have is 0, 1 and 3, and we will start with the length of the array. So in this, 3 and 3 will cancel out, 1 and 1 will cancel out, 0 and 0 will cancel, and only 2 will be remaining. So we will get the answer as 2. So we can start with some number as XOR equal to the length of the array, and then we will iterate from 0 to the length of the array, and we will take XOR of the current number and the index and the number at that particular index, and the final XOR will contain the element which is coming only once. So now we can run this code. Okay, so now this is running in 0 millisecond, which is very fast. So if we discuss the time complexity, it is linear and the space is constant. The time is linear because we are iterating from 0 to the length of the array, and the space is constant because we are taking only one variable to store the results. So this was the third method. Okay, so now we can move forward with the fourth method, which is using the formula for sum of n numbers, which is equal to n times n plus 1 divided by 2. So this is the sum, required sum. So this one we will need, and the sum of the array we will calculate from the given array. So we are iterating through the array, and we are taking all the numbers and we are adding it into the array sum variable. and we will return the difference of the required sum and the array sum, which will give the missing element which is not there in the array that we have obtained. Okay, so we have to define n also, which is the length of the array. Okay, so now it is also running 0 milliseconds. So if we discuss the time and space complexity of this algorithm, the time will be linear because we are iterating through all the numbers here, and the space will be constant because we are storing only constants. Okay, so this was the fourth method. Okay, so that's all for today. Thank you for watching the video, and do like, comment, share and subscribe if you like the video. Thank you.